We present an interactive VR system with a jigsaw puzzle approach for the digital reconstruction of a culture artifact. As a case study, we demonstrate this approach for the reconstruction of a funerary monument that was destroyed during the Second World War. Among the challenges of this puzzle are a large number of 415 fragments, an unknown amount belongs to another artifact, missing pieces prevent a full reconstruction, and the preserved fragments vary strongly in size. The funerary monument was constructed around the year 1610. During the Second World War, it was destroyed on the 18th of September 1944, and the damaged remains of the main structure are still mounted on the wall. The scan of wall-mounted remains is the starting point of the digital reconstruction. In total, 182 fragments could be virtually assembled. All fragments were digitized with a laser scanner to obtain their surface mesh. The resulting data set was too large to be used directly in a real-time VR application. In a worst-case scenario, displaying all fragments at once results in around 369 million triangles to render. To find a reduction boundary that can be applied to all fragments without risking to lose important details, we investigated characteristic pieces such as a plate of weapons with an inscription. Difference in the inscription started becoming noticeable after reducing the resolution to approximately 30%. Reducing the resolution of all fragments to 30% results in around 111 million triangles, which is still too much for a real-time application. To solve this issue, we take advantage of the fact that not all fragments can be investigated in close range at the same time. We created 6 levels of detail for each fragment. Depending on the distance of a fragment to the user, the different levels of detail are shown. The restorer should be able to explore all fragments in a natural and easy way. Therefore, they are simultaneously displayed in a configurable self-arranging fragment wall. The fragments inside the wall can be rearranged via grouping and sorting. The user defines a grouping property first and a sorting property after that. In this example, material is chosen as a grouping property and the fragments are sorted according to their volume in descending order. After pressing the sort button, the fragment wall is rearranged according to the selected properties. For coarse and quick alignments of pieces, the scaled Homer method can be used. To activate this method, the user has to check the Coarse Positioning option in the menu. For precise assembly, a combination of the virtual hand technique and widget-based interaction can be used. The widget allows to manipulate one of 6 degrees of freedom individually. To give the restorer more control, the gain factor can be adjusted for the virtual hand technique and the widget. After the restorer has aligned fragments, they can be fixated relative to each other. For that, the selection mode has to be activated first. This allows to highlight individual pieces via ray-based interaction. After pressing the group button in the menu, all highlighted fragments are fixated to each other. This new group is now handled like a single fragment. To scale all fragments globally, the grip buttons of both VR controllers have to be pressed at the same time. Moving the hands apart after that increases the size of all fragments and moving them closer together decreases their size. A point light is attached onto each controller. This allows the restorer to use them as a flashlight and highlight fine cracks, gaps in the surface texture. A collection of photographs of the funerary monument is presented in an image gallery. These photographs can support the restorer with assembly decisions. The photographs can be manipulated like other interactable objects. This allows to arrange them side by side or use them as direct templates to assemble pieces in midair. For that, their global scale has to be aligned first and then, they can be aligned with the virtual reconstruction. The application was developed in an iterative process with a qualitative evaluation. Over the course of 14 assembly sessions that took around 1.5 hours each, a restorer and a computer scientist used the application alternatingly to improve it and assemble the puzzle at the same time. Overall, 13 fragments were assembled to the main funerary monument per session, 11 were categorized as unsure, indicating that these fragments are either part of the other funerary monument or their location cannot be determined, and 5 fragments were excluded per session, indicating that these belong to the other funerary monument. From 415 fragments, 17% were excluded as they belong to the other funerary monument. Of the remaining 341 fragments, 53% could be assembled, resulting in a finalized virtual reconstruction of the funerary monument, which will now be reconstructed physically based on the virtual results.